Good morning, students. Stand up.
Good morning.
Good morning, teacher. How are you?
I'm good.
Okay, sit down, please. Who is on duty today?
I'm duty today.
Okay, good. What date is it today?
Today is 20th of December.
Okay, good. What day is it today? Today is
Monday.
Monday. Okay, good. Who is absent today?
Ali, Almaz, and Aljan are absent.
To ask homework, Nurjan. In the report.
Which of the following physical quantities belongs to the vector? How do we add vectors that interact at an angle? What is the physical quantity of acceleration?
Work at the today. Балалар қазір сіздермен жамбы ату ойынын ойнаймыз. Яғни бір оқушы шығады тақтаға. Осы садақ арқылы сіздермен атамыз. Яғни қайсы сұраққа келеміз көріп тұрғандай. Бірінші жеңіл сұрақтан бастап күрделі сұраққа дейін барады. Кім келеді?
M1 3 kg and M2 2 kg, which are in contact with each other, are pushed by a force of 20 newtons. What force does the M1 apply to the M2? Solution. M1 F M1 plus M2 8 10 M1 plus M2 F 8 20 3 times 2 8 10 4 M S 2. How to find direction for the draw free body diagram for M2? M2 F2 10 M2 8 F2 2 4 8.
Two boxes are attached with a string. Then a force pulls the boxes in first 2 kg and second 3 kg. What is the value of the tension in the string? Beginning.
I'll explain the reindeer thing later. Newton's first law is all about inertia, which is basically an object's tendency to keep doing what it's doing. It's often stated as an object in motion will remain in motion, and an object at rest will remain at rest, unless acted upon by a force. Which is just another way of saying that to change the way something moves, to give it acceleration, you need a net force. So how do we measure inertia? Well, the most important thing to know is mass. Say you have two balls that are the same size, but one is an inflatable beach ball and the other is a bowling ball. The bowling ball is going to be harder to move and harder to stop once it's moving. It has more inertia because it has more mass. Makes sense, right? More mass means more stuff with a tendency to keep doing what it was doing before your force came along and interrupted it. And this idea connects nicely to Newton's second law. Net force is equal to mass times acceleration, or as an equation, F net equals ma. It's important to remember that we're talking about net force here, the amount of force left over once you've added together all the forces that might cancel each other out. Let's say you have a hockey puck sitting on a perfectly frictionless ice rink, and I know they're not usually perfectly frictionless, but stick with it. If you're pushing the puck along with a stick, that's a force on it that isn't being cancelled out by anything else. So the puck is experiencing acceleration. But when the puck is just sitting still, even when it's sliding across the ice after you've pushed it, then all the forces are balanced out. That's what's known as equilibrium. An object that's in equilibrium can still be moving, like the sliding puck, but its velocity won't be changing. It's when the forces get unbalanced that you start to see the exciting stuff happen. And probably the most common case of a net force making something move is the gravitational force. Say you throw a 5-kilogram ball straight up in the air and then, get out of the way because that can really hurt if it hits you. But the force of gravity is pulling down on the ball, which is accelerating downward at a rate of 9.81 meters per second squared. So the net force is equal to ma, but the only force acting here is gravity. This means that if we could measure the acceleration of the ball, we'd be able to calculate the force of gravity. And we can measure the acceleration. It's 9.81 meters per second squared, the value we've been calling small g. So the force of gravity on the ball must be 5 kilograms, which is the mass of the ball, times small g, which comes to 49.05 kilograms times meters per second squared. We use this equation for gravity so much that it's often just written as Fg equals mg. That's how you determine the force of gravity, otherwise known as weight. Now, those units can be a bit of a mouthful, so we just call them newtons. That's right, we measure weight in newtons, in honour of Sir Isaac, and not in kilograms. Kilograms are a measure of mass, but gravity often isn't the only force acting on the object.
Did you understand an equation?
Why do water animals have fins and tails?
Күнделікті өмірде балалар, әрдайым қандай да бір денелерге біз күш түсіреміз. Есікті ашқанда, қаламмен жазған кезде, алайда кез келген әрекет қарсы әрекетпен қатар жүретінінде ескереміз. Мысалы балалар, ағаш тұрады да, және ағашты адам өзіне қарай тартатын болса, ол кезде біз нені байқаймыз? Немесе адам қабырғаны ұратын болса, қабырғада адамды не істейді? Ұрады екен. Осындай кезде балалар, біз сіздермен Ньютонның 3-ші заңы туындайды екен. Яғни, кез келген әрекет етуші күшке қарсы модулі бойынша тең және бағыты бойынша қарама-қарсы әрекет ететінде күштер бар екеніне. Яғни балалар, біз сіздермен осы бүгін Ньютонның 3-ші заңын қарастырып жатырмыз. About Newton's third law.
Newton's third law of motion states that when one object applies a force on the second object, and the second object applies the same force on
Тоқта.
Newton is first, or Newton'un birinci zаңы.
Окей. келесі балалар.
Body impulse, дененің импульсы. Ньютон
Ана, қайтадан бас. Ниеттілік. Окей.
Ньютон first law, Ньютонның бірінші заңы.
Окей. Very good.
Body impulse, дене импульса.
Окей.
First impulse, күш импульсы.
Окей. Next.
Body impulse, дененің импульсы.
Окей. Наргиз. Ал балалар енді сабаққа рефлексия жасайық. Сіздермен білім қоржыны. Өздеріңіздің қолдарыңыздағы стикерлеріңізді әкеп жапсырасыздар. Бірінші, өте жақсы түсіндім. Екінші, мен сабақты жақсы түсіндім. Үшінші, тақырып бойынша әлі де ізденуім қажет. Балалар қолдарыңыздағы стикерлеріңізді әкеліп, өздеріңіздің таңдауларыңыз бойынша жабыстырасыздар. Homework, learn terms and definitions. Read the text on page 18.